All right, good evening, statistics students. So we are going to start talking about correlation and regression. Okay, what I mean regression is that we draw a line through the different points and send out what's going to happen here. Okay, so there's a couple of things to talk about before we kind of get into it. And let's see here. There's a couple of things we want to address. One of them is that we want to say something like we're assuming a linear relationship between the two variables. Okay, that's always an important thing to do. So one of the things, no matter how many fancy techniques you learn, okay, you always want to go back and make sure that your scatter plot looks something like, does it look like it might be linear? Okay, and it doesn't have to be like this. It could be, if we have a negative slope, that's okay. But if you see a pattern that's goes something like this, where it's, and we're not trying to draw a Rorschach test where it's like, I see a butterfly. I'm like, no, no, you don't. They try to be pretty clear about what you're trying to look at. Okay. So in this case, you will generate a correlation coefficient for this. But is it appropriate to assume that there's a linear relationship going on here? Like, since there's a bend in it, I would say probably not. Okay, so one of the first things you do when you decide, like, well, should I use regression? Should I use correlation? Correlation is a measure of the linear relationship between the two of them, between the two variables. There might be a relationship, but it might not be linear. Okay, that's one of the important things. Okay, so that's something to keep track of. One of the things we're going to talk about is like it has to be measured. Okay, we have to have numbers. Okay, you don't want to say that, well, there's a correlation between blonde hair and blue eyes. Like, well, there's a relationship, but what number is blonde hair? What number is blue eyes? So we have to be able to put it into this formula and calculate a number. So that's an important thing. So correlation, the sample correlation. Okay, that's called R. That's the kind you're usually going to take. Okay, his correlation is going to be called R, and it's almost always it's going to be between R to be between -1 and +1. Okay, if R is -1, then what you have is a perfectly correlated line with a negative slope. Okay, this would be R is equal to -1. And then if you have R is equal to a +1, okay, R equals 1, you'd have a perfectly correlated, a perfect line that you'd find like in an algebra book. Now, this is not saying anything about the value of this slope other than positive versus negative. Okay, so R equals 1, you could also have a line that would look something like this. Okay, and all that matters is, do they line up in a straight line? Yeah. It doesn't, we're not saying anything about the slope. We're not saying anything about the value of the slope. We're not even saying anything about the intercept. Okay, so it could be something like this. All I want to do is have this thing line up, pretend that's straight, and just have that line up in a straight line. Okay, that's all we're saying with correlation, and that's when R is equal to 1. It usually won't be. Okay, so you have to look at your best guess and say, well, does that seem like it's in a linear relationship? And most people fall victim to assuming that there's a linear relationship. You can find that in a lot of people's arguments. Usually, and Americans we're pretty bad about this. Like, if you tell somebody like, hey, a little bit of vitamin C is good, well, then more must be better. That's a linear relationship. Now, with vitamin C, taking too much vitamin C isn't really going to harm your health by too much. But, you take your vitamin A, B, E, and K, these are the fat-soluble vitamins, they stick around. If you eat too much vitamin A, like there's a point at which you've taken enough vitamin A, anything more, your health is going to start going in the other direction. Okay, so this is not a linear relationship, but humans are conditioned to think like, well, if a little bit's good, more must be better. Okay, so that's what we want to do with linear relationship. Okay, that's the assumption that we are making. Okay, and it's okay as long as you know you're making that assumption, then it's okay. But you can't just automatically say that that's always going to be true. Okay, you don't want to do that. So the last thing about correlation is, we're going to say A and B are correlated, and there's a couple of things that can happen here. Did A cause B? If I put more fertilizer on my tomatoes and I get bigger tomatoes, did putting more fertilizer on the tomatoes cause me to have bigger tomatoes? Probably. Um, did having bigger tomatoes cause me to put more fertilizer on them? Doubtful. So it's hard to tell sometimes if A came before B and thus caused it, or B came before A and thus caused it. So you want to be really careful. Causation versus correlation. Okay, you want to be really careful about that. Almost every time in your homework, if you see this word caused, it's almost always a red herring, and they're trying to mislead you into thinking that this is not going to happen. There are some other examples like drowning deaths and ice cream sales happen to be related. So you could think, well, if only we could keep people out of pool, only if we could keep people from buying ice cream, then dozens of people, hundreds of people would be saved by not drowning. There might be a third reason why ice cream sales and drowning death could be related, which is called summer. Okay, because when the heat goes up, right, people want to buy more ice cream, and then people also tend to swim more. And especially if you haven't swam in a year, then it can be tragic. So you have to be really careful, wondering like, is A causing B, is B causing A, or is there a third? These are called lurking variables. Is there a third lurking variable that is causing both? And then is it positive they can be influencing each other? Okay. I can't take credit for this. This is a joke that I heard recently. So like, are you a beautiful person because you're watching my videos? Or is watching my videos making you a beautiful person? Turns out both. Okay. So you have to be careful if you're going to say, well, A is causing B or B is causing A. Just because they're correlated doesn't give you insight to that relationship. It just means that they tend to go up together, or they tend to, one goes up and the other one goes down. And that's fine. Like the age, as time passes, the value of your car is going to decline. Okay. And I don't know if the value of your car is making time pass, or the time passing is making the value of your car go down. With just the correlation, we can't tell. And of course, if you have a correlation R is equal to 0, all it means is like you've just got a whole bunch of dots all over the place. Okay, there might be a pattern. Okay, this would be a correlation of 0. And in this level, they're not asking you for like deep insights into this. If they want you to see a pattern, they'll draw a pretty obvious pattern there. They don't want you to take an ink blot test and say, I see a butterfly. No, you don't. There's a pattern, but it isn't a linear pattern. That's what they're trying to tell you that you're saying here. Okay. So human beings, we find patterns in everything. That's just part of being, that's just a thing of being in our species. Like we find patterns. They might be spurious, they might not be real. Spurious means they're false, and that's another kind of correlation, a spurious correlation. Again, there's a website called Spurious Correlations. There's actually a whole book, Spurious Correlations. Okay, there's a really good correlation between the amount of cheese people eat and then the number of deaths people suffer by being tangled in their bed sheets. Okay. One of my classes did argue that alcohol could be a contributing factor in both of those cases, so that could be a lurking variable. But I actually think that there's no relationship between the amount of cheese people eat, and this is per capita, so this is the amount of cheese that we eat as Americans versus the number of deaths people have by being tangled in their bed sheets. I think the lurking variable is we have more people. Okay. So you have to be careful about spurious correlations. So just because two things happen to have a correlation value, like you can go ahead and find two variables that will have a correlation. That's what this person did with spurious correlations, even though these variables have absolutely nothing to do with each other. Okay, so that's just a little preamble about correlations. So I just want you to be careful about what's going on with this. Then what we're going to do is we're going to go ahead and we're going to calculate this thing. Let me pause this for 1 second, and I'll do this. Okay, so in the book, they do tell us R equals, and they give us this formula, 1 over n minus 1 sum x minus x bar over x over s of x, standard deviation for x's, y minus the average of y's over the standard deviation of the y's. Under no circumstances should you be memorizing this formula. Okay, the calculator does the heavy lifting for us. Okay, I think long ago, I had worksheets where people would actually go through and crank through this. But this was not a homework problem. This was an in-class problem where other people would help. And I would just divide people up into groups, especially during the first day of like an in-person class, so that they could get to know each other. And then I give them a whole bunch of numbers and they would have to go through and crank this stuff out. And I tell them what the answer is. I don't want you to have to calculate this by hand, okay? You're not doing this. So when you have to go through and do this calculation, what you're going to do is you're going to go to your calculator. There we go. And we're going to use the calculator to do the heavy lifting here, okay? So let me go ahead and show us what's happening with the various numbers here. Let me go ahead and move this out of the way. Okay, so what we're going to do is we're going to go to stat. I'm going to go ahead and clear my list. So just in case we haven't cleared everything, we'll say clear list. And then a second function, list 1, comma, second function, list 2. We're just clearing the lists. Now when I go back to stat, we're going to edit, and we're just going to type in the numbers. Okay, so we're just going to have 5, 1, 6, 7, 4. And I'm just using the arrow. I'm just using the arrow key, this arrow key right here, to move over. I actually use the one on the keyboard. And in the Y values, we're going to say 2, 5, 6, 1, 7. Okay. So what we're going to do now is we're going to go to stat. We're going to go to tests. Okay. And in this calculator, I think the 84 actually has a little bit different thing here. So what I want to do is I want to go down to where it says lin reg t-test. Okay, that's going to give me all the information I need to be able to do this problem. Okay, so we're going to go ahead and hit enter. And notice they want, what's the X part? I want that for list 1. That's the values I put in list 1. That's the values I put in list 2. You can change these. Okay, if you put them in backwards, that's okay. We can change them. Frequency, if we had a lot of data that had different frequencies, I hope to God that they did not put any problems like that in this to making two different frequencies, because that's a lot more complicated than we really want to deal with in an intro class like this. Okay, later on, we'll talk about this a little bit. Okay, we'll talk about the regression equation, and we'll just say calculate. So you can pretty much just down arrow the whole thing here, press enter. And then what we're going to look for here is we want the R. We want where's my R? R is negative 0.4447. We're going to put it down to 4 decimal places, 3 decimal places. We'll do what the book wants us to do. So we're going to say this was negative 0 point, and then 1, 2, 1, 2, 3 decimal places. That 4 is going to pop into a 5 because of the 7 is going to round this up by 1. Okay, and we'll check. And then look at that. We have our correlation coefficient. And that's all you're doing with this section. Okay, so again, I just want you to remember, like, hey, be careful. We're assuming a linear relationship. We're making that conscious choice. Technically, I would really want us to do a scatter plot to double check this, but we're not there quite yet in this section. Okay, we'll get there. but we're making we're making an assumption that there's a linear relationship. This is the strength of that linear relationship. This is like negative 50 cents, negative 0.5. It's closer, it's about as close to zero as it is to -1. It's not a very strong relationship. So I wouldn't expect the scatter plot to give us a lot of like a line or look like something that we would assume is a line. Okay, so just to get us started on doing this, and I will be back with some more videos and show you how to do the rest of this too. Okay, so thank you for tuning in, and I will see you in the next video.